An interstellar comet is approaching Jupiter, and NASA just changed its predictions 3 times in 1 month. The latest data on 3I Atlas reveals something unexpected. Its closest approach to Jupiter matches almost exactly with a critical boundary where the gas giant's gravity dominates. Coincidence? Natural physics? Or something else entirely? Here's what's happening with our third interstellar visitor. On the 1st of July 2025, the asteroid terrestrial impact last alert system spotted an object racing through our solar system. Astronomers quickly confirmed it was not from here. This is 3I Atlas, our third confirmed interstellar visitor. The object shows classic comet behavior. It has a nucleus, a large coma, and both dust and ion tails. But like other comets, it exhibits something that sounds unusual: non-gravitational acceleration. This is when an object speeds up or changes direction without being pulled by gravity. At its closest point to the Sun, called perihelion, 3I Atlas was 1.36 astronomical units away. That's about 203 million kilometers. There, it showed a radial acceleration away from the Sun of 135 kilometers per day squared. It also had a transverse acceleration of 60 kilometers per day squared. Here's where things get interesting. NASA's Jet Propulsion Laboratory tracks this comet on their Horizons website. They regularly update a value called A1. This is the radial acceleration component. On the 30th of October 2025, the A1 value was listed as 1.6 times 10 to the negative 6 astronomical units per day squared. By November 24, that number dropped by a factor of 4 to 4 times 10 to the negative 7. Then something remarkable was noticed. The predicted closest approach to Jupiter, called peri-Jove, was calculated at 53.445 million kilometers. This happens on the 16th of March 2026. Jupiter's Hill radius at that time is 53.502 million kilometers. These numbers match within the margin of error. The Hill radius matters. Inside this boundary, Jupiter's gravity dominates over the Sun's. Outside it, the Sun can pull objects away. Another revision, after this coincidence was pointed out to NASA, the A1 value changed again. Within days, it was revised downward by a factor of 6 to 6.8 times 10 to the negative 8. NASA also changed the model they use. The new model assumes carbon dioxide ice is sublimating. This uses an inverse square relationship with distance from the Sunday. The previous model was based on water ice sublimation. That has a steeper relationship. With this new model, the predicted peri-Jove distance is now 53.587 million kilometers. That's slightly outside the Hill radius. But this prediction relies on data from when the comet was farther from the Sunday. There's evidence this new model may not be adequate. Observations suggest 3I Atlas became brighter near perihelion than the smooth inverse square model predicts. The Hubble Space Telescope imaged the comet on the 21st of July 2025. The luminosity is dominated by the coma. This reflects mass loss from the comet. Research by Marshall Eubanks and collaborators shows the luminosity evolution. Earlier work by Qicheng Zhang and Carl Batams suggested a steep luminosity profile inside 2 astronomical units. They found a relationship of 1 over distance to the power of 7, 5. If this steeper profile is correct, it would change the non-gravitational acceleration calculation. The predicted peri-Jove distance would shift back toward agreement with Jupiter's Hill radius. Meanwhile, scientists have been working to explain the non-gravitational acceleration through normal comet physics. A preprint paper by Florian Neukart from Leiden University suggests conventional outgassing can explain what we see. The paper uses thermophysical and Monte Carlo models. It finds that carbon monoxide and carbon dioxide activity can reproduce both the magnitude and direction of the acceleration. Only a small fraction of the surface needs to be active. The models assume modest jet collimation. The paper concludes that exotic explanations are not needed. No special radiation pressure geometries, no unusual compositions, just normal volatile ices heating up as they approach the Sunday. Recent observations support typical comet behavior. The Meerkat radio telescope detected hydroxyl molecules on October 24. Hydroxyl comes from the breakdown of water ice. Dr. Cyril Opitom from the University of Edinburgh explains, this means the comet is currently releasing water. This is expected for a comet that just passed its closest point to the Sunday. Earlier observations didn't detect water because the comet was farther away and fainter. Non-gravitational acceleration is not unusual for comets. As ices heat up and turn to gas, they create jets. These jets push the comet. It's like a natural rocket engine. We see this in comets from our own solar system all the time, but tracking this acceleration precisely matters for predictions. Getting it wrong means the comet could pass closer to Jupiter than expected, or farther away. The difference of a few 100,000 kilometers might not sound like much, but in orbital mechanics, small differences matter. The statistical likelihood of the perigee distance matching the Hill radius by chance is less than 0.00004 within Jupiter's orbital diameter. That's very unlikely. Some have suggested this could indicate a technological signature. The idea is that an artificial object could release devices as satellites of Jupiter. These might park at Jupiter's Lagrange points, L1 and L2, on the Hill sphere. Those locations require minimal fuel for orbital corrections. However, this remains speculation. The simpler explanation is that our models for the non-gravitational acceleration are still being refined. Part of the difficulty is timing. 3I Atlas was hidden behind the Sun from Earth-based telescopes during its perihelion passage. That's when it gained most of its non-gravitational acceleration. We can measure the total drift from its gravitational path, but we don't have detailed measurements of exactly how that acceleration varied close to perihelion. We'll know more in the coming months. As 3I Atlas approaches its closest point to Jupiter on the 16th of March, 2026, observations will continue. Data from spacecraft like Juno, JUICE, or Psyche could be very useful. These missions can provide astrometric data that ground telescopes cannot. The comet is also becoming more visible to optical telescopes as it moves away from the sun's glare. This interstellar visitor may be a 10 billion-year-old time capsule. It formed in another star system and traveled through the galaxy to reach us. Understanding its composition and science is work in progress. Models get updated as new data arrives. NASA's changing predictions for 3I Atlas show this process in action. Whether the final perigee distance matches the Hill radius or not, we're learning from an object that came from beyond our solar system. The truth will be determined by observations, not by authority or speculation. And that's exactly how science should work.